Hello everyone, and thank you so very much for joining me in a new playlist. Today we start with the first episode where we discuss Troubleshooting Java chapter by chapter. Is the third book I wrote and it has been published in several languages. I wanted to show you the cover of the paper book, and then I have realized that I only have the Korean version. This is the Korean version and the Russian version. But I actually have no English version with me because I've given all the copies I had. I sold the last one a couple of weeks ago, and I need to make a new order. So sorry for that. I will have to show you the cover only in pictures for now. But you will trust me, it has been also published in English. With that being said, it's a great opportunity to discuss about troubleshooting techniques, which mainly include reading code, debugging, and profiling, sampling and profiling, and of course investigating logs. And this is what we're going to discuss as a main subject, going chapter by chapter, section by section through the book. If you will be here with me live, you have a live chat and you can ask your questions and of course start discussions in the live chat, and that let's make this interactive. And of course the Discord server we have created together out there is for more interactivity in between the videos and the live sessions I create here on YouTube. But with that being said, let me go straight forward and share you my screen, because I want to already start discussing the book before you get bored. And we start with of course the part one, and then we will go chapter by chapter throughout the whole table of contents. So what do we have here? We have the first part here where we discuss the basics of investigating the code, meaning that we first go through a discussion about what these techniques are and the entire philosophy of using them and combining them to discover how a code base works and how an application works, or even how a system works, because today is very important to also understand interaction between different applications, since we discuss about usually more services communicating, discussing with one another. No, the applications today that are no longer simple applications, they are cloud deployed applications, large ones that are communicating in several modes, and we want to know how to properly understand how they work together. Sometimes the problems come from the interaction in between the applications and not necessarily from a single application. So there are a lot of things. It's a very complex subject. That's why I wrote an entire book about it. And to be honest with you, I think I could write even more. And actually this book is now, I have a second edition in progress. So now I want to discuss with you on the text I wrote of the first edition, because this is published already for a couple of years. And I mean, it makes sense now to work on a completely edited book rather than something that is not yet published. But be aware, because this is now, so I do have a second edition in progress where I will add some AI techniques I have learned throughout the past couple of years since the AI hype started, and also something related to GC logs, the garbage collector logs, which are sometimes very useful when you talk about performance improvements, because sometimes by making some tweaks in the garbage collector configuration or simply just changing the garbage collector all throughout, it's going to change completely the way your app executes. No, so a lot of things to discuss. Again, thank you very much for being here with me. Remember, you have the live chat if you want to ask questions or start any kind of discussion. We'll try to stay on the subject as much as possible, but I will from time to time deviate to tell you different maybe stories about my experience with different debugging techniques, the way I've used them, combined sometimes, how in my experience I think is best if you combine them, in what situation should you think about choosing a specific technique, and in what situation should you choose a different technique. So part one is discussing about the techniques in general, and then it goes through debugging. So the first chapters 2 and 3 actually they are go through debugging. Chapter 4 is actually going through debugging remotely. This chapter actually I will not remove it, but make it only one section in the second edition. I will explain you why at the time, so maybe we will actually skip it here as well in this discussion, because I've realized that it's just too much taken out. No, it's just too much emphasis on this technique, when it's actually only basically connecting remotely to do the same thing that you do locally. But I will explain everything to you. Now this comes with experience of also writing. No, you can't always make something very good from the beginning. So this first edition, I consider I can add a lot of improvements, and that's why I'm also writing a second edition. Is not only adding that AI part and the garbage collector stuff, it's also by improving the structure and maybe even the content a lot. So if you intend buying the book, of course I do strongly recommend you go directly for the second edition, because it's better. No, that's why it's the second edition. So I hope you can trust me that is second edition will be much good than better than the first edition. And then we will discuss about the logs. And again, about logs, this is kind of how you read the logs, but also how you create your logs, how you write your application to have in the end very well written logs that you can use for investigations. And I was telling you that in the second edition I'm discussing also about garbage collector logs, which are also very important. No? And then part 2 is about X-ray scanning your application through sampling and profiling. Sampling and profiling, they are very important techniques that allow you understand the execution of a process, of a Java process, first of all, even without looking in the code. So you might see what exactly executes behind the scenes without even having the code base. In some cases we are just going from profiling to debugging, so it's the other way around, because you want to actually understand first what you want to debug. There are cases where you don't know where to put a breakpoint, so there are cases where you need to X-ray your application through profiling to know exactly where to put a breakpoint and then start a debugging session from there. So I read your book in Korean translation and I think it's really good. Thank you very much for your appreciation. So yes, this is the Korean. I hope this is the one you're reading. I have one with me here. I understand only the Java part out of it. Sorry for that. And the book, yeah, indeed is translated in multiple languages. I think it's even translated in Chinese. I don't have all the copies, and now I'm actually lacking the English one as well. So unfortunately for me. Okay, and with that being said, no, and then we discuss about logs. We discuss about memory issues and how you use heap dumps, thread dumps for investigating thread-related problems, and even how communication between apps works. So a lot of things to discuss here. So the point is, and now I'm starting with part one, the basics. Now I was saying that this is the road we are going to take. We discuss about reading code, and I will link a lot our discussion about reading code to also maintainability and how you write the code. But reading code is different than writing code, because you see, when you write code, and like I hope all the professional developers out there, you write the code in a clean way, in the way in which you'd love to be able to read the code later, no? But when you read code, you may need to read code that hasn't necessarily been written in a way that makes it easy for you to read it. And that's when we, for example, investigate very old code bases. Very old code bases that were written when the principles, the things that we learn today in regards to maintainability and clean coding and stuff like that didn't exist. No, today we have plenty of material out there to learn from the very beginning what maintainability is and how to write proper code. But we know that these things came with evolution, and whoever had the chance to have to look through an older code base also know that things like spaghetti coding, God objects, big ball of mods, and all the other kind of fan type patterns do exist, and you still need to be able to investigate them, because some of those applications are still there working and you need to be able to understand them. If you want to be a really good professional, you need to be able to understand any application, to not be afraid when you have to investigate any code base, even if you haven't seen it in your life. I've seen sometimes developers telling me, hey, I'm afraid about the task I'm going to have to solve because I don't understand the code. And then the question is, why exactly? What makes you afraid? Actually, the fear comes from not understanding, or the fear comes from not being able to quickly enough use some techniques to understand. The reality is that Java code is Java code, and if you know the fundamentals, you can always understand any application as long as you also have with you some proper troubleshooting techniques. And this is exactly why I have created this book, and why I recommend this book for all developers, from the beginners to even experts, I would say, at least as a refresher. No? So let's start with chapter 1 and discuss a little bit about what troubleshooting is in general. No, one of the notes here, and one of the things that I believe in, is software developers generally spend more time understanding how software works than writing the code. So, you know, many people ask me, hey Laurentiu, why aren't you learning more of the features that, I don't know, your IDE, IntelliJ or Eclipse or whatever you use offers you? Because I see some developers, some of my colleagues, now they are so into that, and they know all the shortcuts and they know everything. I know a few of them that I am using on a daily basis, but then they ask me, why don't you actually learn more about all these shortcuts and everything? Because see, you can like immediately extract a method, you can immediately create a new class, you can immediately. And then I say, okay, that's pretty cool, but the reality is that more important than writing fast code, it's reading fast code. So if you read fast, if you create a model, a mental model where you can quickly read the code and understand the code, that's a lot more valuable than writing the code. Because when we work as software developers, the majority of the time that we are spending is in investigating a proper solution, reading existing code, figuring out how to write an algorithm, understanding and communicating with the stakeholder to find out what their need is. And the smallest of the amount of time that we are spending is actually writing code. So yes, knowing your IDE very well, it's a very good skill, but it will just bring you such a little bit more advantage than if you properly understand how to read code, because that's where the most amount of time is spent for you as a software developer, design lead, architect, and so on and so forth. So let's from here, because why I've emphasized this, why I've even put it as a note, I've emphasized it because that is what brings value to the things, brings a lot of value to the things that are put in this book. Because in this book you are going to understand, to learn techniques to understand how to read the code, debug executions, profile executions, and even use different tools to understand how some executions went even after they've stopped, which is something we use, for example, in post-mortem analysis, which means analysis of a problem after the application, after the process stopped because of that problem, like in case of memory issues. No? So even though this word debugging here, it's sometimes used to mean troubleshooting, in reality troubleshooting is a combination of multiple techniques, and the main techniques are reading the code, investigating the logs, debugging, and profiling and sampling. So these are basically the main points. When we say I want to debug something as a developer, sometimes developers refer to either of these techniques. For some reason we sometimes use debugging instead of troubleshooting, but the reality is that, and that's why the book is called not debugging Java apps but troubleshooting Java apps, is because debugging is in reality only one of the techniques that you can apply. And then what can you apply it for? Because sometimes I see developers understand troubleshooting because of the word, or debugging because of the word, only as an investigation with the means of solving a problem. And the question is it that right? Is troubleshooting only meant for finding out the root cause of a problem? And the truth is that I and many other developers in reality use debugging and troubleshooting techniques for much more than that. For example, I always use troubleshooting techniques for learning new frameworks. People ask me, how did you learn Hibernate so well? Of course, it's not only troubleshooting. I've learned Hibernate through many means. I've read books, I read the documentation, I read the JPA specification, I read articles, I follow people on social media that are passionate about Hibernate, like Vlad Michalcha, for example, and I learn from them. But one of these is also I did go through the framework itself. And when I was writing my own examples, even theoretical examples, but sometimes even in practically applied, like in real applications, I even took some time to go and debug through the code, through the real code of Hibernate, to understand when I do something, what really happens behind the scenes. And that's how I basically I've learned pretty well how the framework works, just going behind the scenes and trying to find out. And that's the same I did with Spring Security, the same I did with many parts of the Spring framework. All frameworks that are open source, and remember with Java, the majority are, allow you to go and debug on the framework's code. Don't be afraid to do that. When learning a new framework, start going through the unknown code of that framework. And at the very first glance, it will look like foreign. You will not understand many things out of it. But then it will soon become more and more clear. You will realize patterns. You will realize that when calling your endpoint, you are entering a specific filter every now and then. You will understand then how the filters are managed. You will understand that the dispatcher servlet is triggered in specific cases, and in other cases it isn't, and you will just make patterns, but to make these patterns, you have to see the code. And in most of the cases, you cannot simply just see the code by reading the documentation. No, it's much better to go and do that on your own. And that's why first point here, learning a new library or framework using troubleshooting techniques for that is a very good hint, a very good approach. I've tried it myself and I continue to do that. And then of course is finding the root cause of a problem, which we know, and then it's understanding existing logic, but for the means of extending it. Sometimes I have to evaluate applications for my clients, and in most cases it's about like old applications. The most frequent question I get is, can we still use this code base or do we have to rewrite it? Usually when I get this question, it's already on the table to change that progressively with a new system. But then I have to investigate it. And how do you think I'm investigating it? What am I looking at? When I'm investigating a code base, usually an old and large and maybe badly written code base, the thing that I'm looking at is how easy it is to extend that code base with new capabilities. Because that's where the profitability in my experience comes from. And the more close to technical bankruptcy an application is, the hardest is to extend it with new capabilities. The point usually about continuous architecture, which is another concept that we're going to discuss in another video or another discussion, is to keep your systems and to keep your applications easy to extend, because that's where the profitability comes from. If you continue to have an app easy to extend, it will you will be able to use it and change it forever. The least possible is to extend it, then the more close to the technical bankruptcy that application is. But in order to be able to evaluate that, you need to have in your pockets debugging, troubleshooting techniques to understand how that application is, what means extending it, at what point, up to what certain point can we extend it, what means changing an existing capability, how difficult is that, and that's how you evaluate the profitability of a system. And that's how you end up with the conclusion, should I rewrite completely that application? Can I reuse it? Am I able to progressively rewrite it by extending it progressively? There are many discussions here, more related to architectural nature, but that's basically, again, starting with, you need your troubleshooting tools to be able to do that. So now, of course, I was already telling you that debugging, now we have the word debugging, debug, taking out bugs, but in reality, it's not always about debugging. No, it's finding issues, but it can be simply understanding how software works, learning something new, and something like that. And this is my favorite. So, I always ask one of my friends to draw me pictures. This is basically how I feel when I'm at some point I'm going into the zone and like I'm struggling to find out something. I have an objective, either that, for example, I want to understand how something works, or maybe I simply have to find out the root cause of a problem. I really feel like Lara Croft or Indiana Jones in one of those movies, no? So we say we were talking about these troubleshooting techniques. So reading the code, debugging, and log analysis, which is reading logs and understanding them, profiling, analyzing of the thread states using a stored thread state dump, and analyzing of the memory throughout either sampling of the memory or heap dumps, and mocking and stubbing, which is a very good technique for investigating communications between applications, meaning, for example, in a service-oriented architecture or in a microservices architecture, you want to see if a specific problem is caused by the interaction between two applications, communication between two applications, or among multiple applications, rather than something that comes from the application itself. And then, yeah, I do actually recommend this book, The Programmer's Brain. It's a very interesting one. It gives you a little bit of an idea about how our brain works when trying to work on code. So I'm not going to go in more details than that, but this I really liked. I felt that I understood better myself when I read this book. So I can't say that it will give you necessarily a troubleshooting technique, but in a way or another, you'll understand, for example, why we write the code in a certain way and how it helps us when reading it, for example, or how our brain works when dealing with a specific capability that's running. That's why I recommend this book directly. And now I want you to take a look at listing 1.1. This is a challenge for you. Tell me, what does this piece of code do? So I would give you a few minutes, but we don't have but just take a look at it. Like, if I would see something like this in my application, I would instantaneously get a feeling between shocked and scared. I'm not sure which exactly would that be. It's either shocked or scared, because it looks like very difficult to understand. See, the try catch being used here as a decisional decisional structure. No, you can see it. The fact that it uses here the ternary operated, it using a recursion at the same point. So you can see the recursion here is not only using a recursion, but it's also negating that recursion. Ooh, and it's using not only one exception, but a couple of exceptions as decisional. So it's kind of like a switch in a way or another. So it's very, very difficult to really get. No, I'm not one of the guys. I'm pretty sure out there are developers that can easily read this piece of code. I'm not one of them. But the reality is that all this actually gives you the maximum between the two numbers, if I correctly remembered. So I'm not sure exactly, but I think that's basically what it does. But if you take the book, that we won't do that ourselves, but if you take the book, the recommendation is you try it yourself and actually try to debug over it and see what happens. So yeah, it calculates the maximum between the given inputs. That's actually what it does. Again, you might be one of those who immediately observe what it's doing. I'm not one of them. I would need some techniques to debug over it and understand what it's doing. And to be honest with you, I think it would take me quite some time to understand this very small piece of code. Now, unfortunately, the reason I've added this piece of code here is not to shock anyone, but to actually tell you that this is a simplistic example of what you find out in real life. Of course, in real life, you will not find the maximum between two numbers, but you will find getting the, I don't know, greatest value in a set from the database, getting the biggest price of, I don't know what kind of overlapping periods, so on and so forth. There are so many cases, and you find these blocks of code, sometimes poorly written, with different things applied, and sometimes even put in a multi-threaded way, which makes things even more difficult to debug and understand. But you will find things like this in real life, and that's why it's important to go over them and over these kinds of examples together. So what are the typical scenarios that we discuss when we want to debug something? Is basically either a wrong output. I'm going to go directly through them like this, one-to-one, demystifying unexpected output. What means unexpected output? From now on, when we talk on examples of this book, when you hear about unexpected output, it means that something should have happened with the data and it didn't. It can be that you call an endpoint and you expected to see in the response something, but you see something else. It can be that you call a method that stores something in a file and it stores something differently than you expected. It can be that you store something in a database or change something in a database and the change is not what you have expected. So output is not necessarily, I don't know, something in the console, or is not necessarily something in the response of the endpoint. It's any kind of change, addition, or read that provides you with a different thing that you were expecting. So that's an output problem. When we talk about an output problem or an unexpected output problem, that's basically what we are talking about. So you have here some examples. Now you have again this code that you have seen also a little bit earlier, and this is an example of how we debug it. So to debug this a piece of code, we can use breakpoints, which is just a way to tell your IDE, please pause the execution on a specific line, and then you start your application and your execution pauses on the line where you have specified it, and then you can step by step go through it. That's the easiest point where you can do that and have an output problem that you can reproduce. Then the easiest is to use simple debugging. Now debugging can also become complex, so we will not only discuss about using breakpoints and stepping over. You will see that in given cases you have to know how to step into, step out of, and in many cases you might not be actually able to use debugging and you have to replace debugging with logs or sometimes even profiling. No, but the easiest when you have an output problem is when you can reproduce the problem. You have a single thread architecture, so you don't have problem with thread concurrency, and then usually you can simply add a breakpoint and try to find out where the code doesn't behave as you would want it to behave. And again, a tip here or a note from my side is remember that we will start with this book by discussing investigation techniques one by one. But then progressively throughout the book, we will continue with mixing different 2 or more techniques to find out where a problem is. So you will see that even if now we are discussing about debugging or logs or profiling, we will progressively go into scenarios where it's not enough to use debugging. So for example, take even this case here. Debugging works like this with some constraints. First, and the biggest of the constraint is you know exactly what piece of code to investigate, which is not necessarily the case. You don't always know what piece of code executes. Imagine exactly the idea of trying to learn how Hibernate works. How do you know what class to find in Hibernate and where to put a breakpoint? You cannot. At least unless you have a, I don't know, special crystal globe that tells you what classes in Hibernate should you put a breakpoint in and which of the methods at a given case, or you know them by heart for a reason or another, which I don't think it's really always encountered, you need different techniques for that. So debugging is pretty easy, and it's something that usually developers start with. Normally they start with learning how to debug their code. We will apply this also in chapter 2. So next time when we meet together here for this playlist, we are going to work a little bit on debugging techniques and talk about what you can do with the debugger. But remember that the debugger is not always working. And then secondly, even if you know where to put a breakpoint, maybe you know what code executes and where to start your investigation from, you might not be able to add to use breakpoints, because, for example, in multi-threaded architectures, by using a breakpoint, you might go into something that is called Heisenberg execution. Now, for those of you who for whom Heisenberg is not known, he was a physician. He was a physicist, a scientist, a doctor in physics actually, of the last century, and he discovered this uncertainty principle is called. So it's about a particle. You cannot observe both its energy and velocity at the same time. Now, that's of course nothing to do directly with Java, but the point is that when you have two threads executing, if you put a breakpoint in one of them and you pause one of them, the second one will act as its only one. So instantaneously, you might change the way the concurrency works, which might change the output in a way or another. So there are problems that you might not be able to reproduce anymore when you use a breakpoint. That's what we call Heisenberg problems, because they act like exactly like measuring the energy and velocity of a particle. What Heisenberg principle was telling us, like in physics. And we will talk more about this. No, so if you don't know where to start your troubleshooting from, then one of the things you can do is sampling or profiling, which we will learn in the second part of this book. You use a JProfiler or Visual VM or any other. There are a few profiling tools out there you can use. Visual VM is one of my favorites simply because it's free, and in most of the cases I could do everything I wanted with it. But look what it does. It's actually, you are sampling a piece of code. This is what executes at a certain time. So you can see here that in my case, when I've started the execution, I could see exactly what methods from netty in this case are executing on a given thread. So I know when I'm, say, running something, I have a query that's executing and I want to investigate how Hibernate executes that query. I'm sampling that and I can see what exactly from Hibernate executes at that time. So I know what class to open and in what method to add a breakpoint. And it's not as easy as it sounds. There are complexities in this as well. We are going to discuss them in the following chapters where we discuss profiling. But point is, sampling and profiling, or the usage of a profile, is like use some X-ray machine where you see through the execution of the application, and this might give you the needed clue of where to put a breakpoint when you don't know where to put a breakpoint. And then, of course, we have scenario 3, my favorite, a multi-thread application, and that's where you know I was telling you about the uncertainty principle. Heisenbugs. So Heisenberg execution, it's an execution that can be you interfere with when using a tool from outside, such as a debugger or profiler. The debugger is the one that in most cases interferes badly with executions of multi-thread applications. Profiling may also interfere. That's why in some cases we have to use logging. Logging can interfere as well sometimes, but that's a different story. We are going to go into all the details with the next chapters. Heisenbug is when we call this kind of bug that doesn't reproduce anymore when you try to investigate it. You know, so you have a bug which can be, I know, an output problem, for example. Usually Heisenbergs are usually output problems, unexpected output problems. We talked earlier about unexpected outputs, no? And you can reproduce it at will. So of course, because you can reproduce it, you think maybe I should use debugging, no? Because that I was telling you a little bit earlier, when you can reproduce a problem at will, usually the easiest is starting to debug the code by using the debugger. You put a breakpoint and then you try to go step by step until you find what part of the logic doesn't correctly work. But then the Heisenberg usually happens when you have two or more threads working together in a multi-thread architecture. So if you add a breakpoint in one of the threads, then suddenly the bug doesn't reproduce anymore, so it hides. That's a Heisenberg. So it's a bug that doesn't reproduce anymore when you try to investigate it. And that actually makes it a little bit more difficult to understand. So that's what we call Heisenberg and Heisenberg execution. Read about Heisenberg. It's a nice story. He was one of the most emblematic persons and scientists of 20th century, and he had a very big impact also in World War II. It's a big story out there. I think they also made a movie about it, about him and about his story. And take a look about it. It's interesting. Not related to software development and Java, but still very interesting. Yeah, so this diagram tries to explain you how the Heisenberg execution works. Now, normally instruction A, when you run it, happens before instruction B, but these two threads, they are concurrent, they run in parallel. So sometimes, depending on what your CPU is and how the code is synchronized behind the scenes, you might have A running at the same time with B or A running after B. So see, in this case, if you pause the execution here with the debugger, how we will learn to in the second chapter, then A automatically now happens after B. And because of that, your bug doesn't reproduce anymore, or the output is totally different and is not something you can investigate anymore. And then debugging doesn't work on these cases. And then sending wrong calls. Okay, that's related to the last part of the book, the interaction between. So we are stepping from debugging an application to debugging a system. And then how do you investigate the problem when you test this app and then you test the other app? Both of them, they work fine, but when they are put together, they don't work fine anymore. Of course, in this case, you empirically realize that there should be something with the communication between the application. That communication can be done through gRPC, through REST services, through event-driven architectures. How do you investigate this case? And that's what we are going to discuss in the last part of the book. No, you will see basically that one of the ways is using a stub, which is a fake application that gives you the possibility to understand what the other one sends. And then I'm gonna go fast. You already understood, and I have already detailed you a lot on how I learned myself a lot of frameworks by trying to go deep inside them and understand how they work. No, so this is my advice, and that's also why I took it out as a tip here. Always try to go deeper in the framework. Don't simply rely on understanding that if in Spring you had, I don't know, or auto-wired or transactional, or I don't know, it works. Try to find out how does that work. It's exactly I was making this comparison with you don't only need to be the driver of a car. You want to be the mechanic. You want to understand not only how to drive the car, but also how to fix the car. Okay, so that's why that works with libraries and frameworks as well. Don't only try to be the driver of the framework, try to be the mechanic of the framework. And of course, a very good advice for you, try, if you have the time, to work on open source, because that helps the community and that helps you learn better the framework. And I know it's not easy, and I know you have to allocate time for that, but it just makes you better. No? And then you have the performance problems. Performance problems, and performance is not necessarily slowness. I'm just clarifying slowness. Slowness problems are a part of the group of performance problems. We're going to go more deeper with this when we talk about profiling. But then you have these kinds of problems that are not output problems. They are simply, the output is fine, but it just takes more than you expected. So it's not according to the non-functional requirements of your application. Like, for example, you try to you click on a button and it takes 5 seconds. You load the page and the table on the page loads in 15 seconds. Too long for the user to wait for. Or you have a scheduled process and that process takes a few hours instead of a few minutes. How do you evaluate where the problem comes from? It's not that easy because it can have several root cases. It can be an output problem. It can be an input-output problem, which I don't want you to make a confusion with unexpected output problems. When I say input-output problem, I/O problems. I/O problems meaning the communication of your application with something external, like the file system, a database, or even another service. So I/O issues cause a lot of slowness problems in my experience. But then it can be also multi-threaded architecture that is strongly synchronized. So locks in a multi-thread architecture can also cause these kinds of problems. To investigate that, we usually use profiling tools, and you remember you've seen it upwards, the same diagram, no? But instead now I'm showing you more than just the fact that you can see the code, but with the correct operation of the profiling tool, you can also see the amount of time a given method spends on something. So how regular are you planning to do these sessions? Usually I'm doing them weekly, but remember, friends, that I'm a super busy person. I have not only a job and a family, but I also have conferences I usually have to attend, and I'm writing now at the moment a couple of books. I'm working on another couple of books. So please forgive me for not necessarily being here with you weekly as I wish. Sometimes I'm also having business travels. So I will try as much as possible to schedule my sessions weekly, but it might happen that I have to reschedule them and to have them less than weekly. Thank you for asking, by the way. And you know I'm trying all my best with this channel and with the Discord server and everything I make for the community, but that's, yeah, you know, I'm trying to accommodate everything. And of course, understanding app crashes, which actually means investigating usually means investigating post-mortem situations. So this is your application crashed, and then you want to figure out why it crashed and solve the root cause of the problem so that it doesn't crash again. And again, in many cases, crashes like this are either because of wrongly synchronized threads in a way or another, or memory issues like out of memory problems. If you see an out of memory error in the log, then usually this means you have to investigate your problem with a heap dump, which is something we'll discuss about, I don't know, in chapter 11, in chapter 11 probably, no? So that's have you finished the spring course live session? If it's about the spring start here, no, I haven't. I will have to schedule more, no, because I will go up to the end of the book, so I'm going to discuss everything up to the last chapters, like I'm going to do with this book as well. And what else? So, oh, and now this is kind of a dummy example that's proving an out of memory. See, I have a list here and I'm continuously adding objects in the list, strings in this case, and because I don't remove the reference in a while through, this will cause a memory crash. But we are going to discuss more about this like in detail when we reach the chapter about the memory. Now you will see that, see, in this case, this is how I'm using a profiling tool to see the memory, and you see here there are 10 million, more than 10 million, almost, I don't know, 10,700,000 string objects in the memory of the running application, because I'm putting here these strings and I'm never removing the references. Okay, so that's basically it. You see the product and you see the string, and you see the product here and you see the string, and you see they are very close. They are very close, the numbers are very close, which is normal. And see, when you see this kind of pattern of a large number of instances of multiple objects, and that large number is close, or sometimes you can see it twice, no? That means you have some kind of a reference, how it's called, the link between reference. You can figure out that, for example, this should be a link, there should be a link between the string and the product here, because it's very unlikely to be simply just happen, no, to be the almost the same number, no. So you can figure out here it should be something like the product owns this string. And why is this important? You might ask me, okay, why is this important? Because in some cases, this is just a dummy example, no, it's a very simplistic example created for the book, but in a real life, it's very difficult sometimes to figure out where this product comes from, who's creating it. I will show you that there are ways to see the code sometimes as well, but it's still sometimes it's difficult to see what kind of product is or something like that. And then it helps you by putting some pieces of the puzzle together. It helps you figure out exactly what object or maybe where it is created. So you might see that, for example, the product has a string and a double, which is the price, or a big decimal, which is the price, and then you realize that it cannot be the product, for example, in a specific part of the application, because the price is not set up there. It has to be the product in a given part of the application that you know where the price is also set up. So all these pieces of the puzzle you will learn with time and experience, that you can put together to figure out where the root cause of the problem is. And normally, as I always say, knowing the application up front, it's always better. So if you are in the situation where you know the application up front, you know where to look. But that's not always the case, because as I've told you, sometimes myself I have to investigate pieces of code that I've never seen in my life, and then I still have to put all these things together and work a little bit like Sherlock Holmes to find out where the root cause of the problem is. You hate object query language. I do hate it as well, but to be honest with you, I rarely get into using it. Fortunately, now with ChatGPT and AI, when I had to use it, it was a little bit easier for me to put it, because you can just ask your AI assistant, hey, create this OQL for me, and then you just copy it, and usually it's correct. You have to still review it, but in many cases, in most of the cases, maybe in all, it just gave me the correct OQL query, so I could directly use it. So and this is how a thread dump looks like, which can be something you need when you deal with deadlocks, for example, or multi-thread architecture problems like live log starvation or race conditions. So pretty bunch of things to learn in this book. It's not a simple book. No, that's why I was saying it's a book for both for an entire spectrum of developers from junior to experts. In my experience, and readers who sent me messages over social media or even in real life at conferences, they've told me, some of them more entry level, they told me excellent book, I've learned a lot of things. But even I had even senior developers telling me, hey, I really like the fact that even if I knew some of the things there, I still found some techniques I didn't know about, or which inspired me on how to solve a given solution. It's not an easy book. Troubleshooting Java is not simply just literature and showing you how to use debug breakpoints. It's a bunch of techniques that will, if you know them and you know how to mix them, will allow you to solve any problem in Java applications. That's the book's purpose. So you will basically learn a lot of stuff. I'm not going to read the bullets for you, but you will trust me that all these techniques are invaluable, because it's what I've learned throughout many years, not only from my experience, but also from my colleagues' experience, from different situations I've had throughout my professional life, and I put them all together as a collection. Or as a collection of experience in this book. So with that being said, I'm done with the first chapter, and next time we are starting with debugging. So we are going to start with the simple debugging techniques, and then we are going to go into more advanced techniques and talk about how you can mix them together. And that's basically, this was the first episode. And I'm very happy that you were here with me, and I had so many of you here, and you also put your comments in the live chat. Please continue to do that. If you are not on the Discord server, join me on the Discord as well, and let's talk more about everything that Java related. In the next episode, we're going to continue with the next chapter, our discussion. Until then, thank you very much for being here with me, and have an excellent time for study further. Cheers, everyone.